Hi there. My name is Runar. I'm coming to you live from my basement, and I'm one of the co-founder of Unison Computing, and I'm going to be solving one of the harder exorcism exercises in the Unison track. So first, let me just share my screen and tell you a little bit about Unison here. See. There. All right, so Unison is a purely functional programming language. Its main sort of feature is that code is content addressed, and the code base is an immutable data structure rather than a bunch of text. And you'll see how it sort of feels to program in this. And what we're going to do here today is to solve the one of the exercises, an exorcism. Okay, so I kind of just want to get right into it. The Unison website is at unison-lang.org, and we're going to be making use of Unison Share, which is sort of the code catalog, which is share.unison-lang.org. And I'll be trying to monitor the Twitch chat, but you're also welcome to join the Unison Slack, which is linked from the top of the Unison website. So, come say hi. And hi, how are you? I hope you're having a beautiful day. So let's get going. So what we're going to be doing is solving one of the more difficult exercises in the Unison track. So if you go to tracks in Exorcism, and I have joined the Unison track, so you can search language tracks and find the Unison track, and once you click on it, you'll get a bunch of exercises. Now, I've solved some of these, and I'm currently struggling with this zebra puzzle. Okay, so if I go to that, and I say continue in editor, here's the sort of code to get us started, and these are the sort of instructions for it. Okay, so why don't we just read this together? Okay, solve the zebra puzzle. So there are 5 houses, and then a bunch of constraints. So there are 15 constraints. Norwegian lives next to the blue house. Englishman lives in the red house. Spaniard owns a dog. Lots of different sort of properties of this. And what we are trying to do is find out which person drinks water and who owns the zebra. So each of the 5 houses is painted a different color. Their inhabitants are of a different national extractions, own different pets, drink different beverages, and smoke different brands of cigarettes. Oh, they shouldn't do that. Okay, let's see. So for folks who are interested in practicing using Unison abilities, you may want to look at the each ability. Oh, that's a good idea. So what they're suggesting here is for us to use the each ability in Unison to solve this exercise. So each is a sort of list ability, so the ability to execute some code over a bunch of values, so like each of some values. So that's a good idea. So the way I'm thinking about this is that this is a logic puzzle, and there's some arrangement of the houses where there's one person that lives in each house, they smoke a particular brand of cigarettes, and they own a particular kind of pet, and we're going to figure out which is which. And I think this is going to be a process of elimination. So we're going to go through each of the possibilities and then eliminate the ones that don't make sense. And hopefully what remains is the answer. Okay? I think that's it. So let's look at the each ability just real quick. So if we go to base, that's the base Unison library, and we hit search here, and it says say each. Each is a structural ability. It is a non-determinism ability that produces output lazily. It can mimic list comprehensions. So here's an example. So each to list do. So A is in the range 0 to 5, B is in the range 0 to 5. List everything that's less than, or A is less than B. Okay? And then it comes out with it. So what this each thing does is that when you say each dot range, then everything that's below this line will be executed once for each value in this range from 0 to 5. So 0, 1, 2, 3, and 4. So A will get those values, and then B will get each value from 0 to 5 exclusive, so 0, 1, 2, 3, and 4. And then this guard will eliminate all the values that don't meet this criteria. And then for each such value, it will return the pair A and B. Okay, so we're going to use something like this. All right. So often when I'm solving puzzles in Exercism, I like to just edit them here in the editor. But since this one's a little more complicated, I think I want to just use my editor, which is Vim. So we'll just use Vim and but just paste it in here when we're done. I think that'll be the best experience. So we can have the direct response from Unison. Okay, so here I have. So here I'm in an empty directory that I'm just calling Scratch. And I've opened Vim with a file called scratch.u. So if I open the Unison Codebase Manager, UCM, actually let me make this bigger. Whoa. Oop. There. If I open UCM, then fail to obtain a lock on the codebase. Oh, I guess I'm running UCM in a different window somewhere. Well, Alt-9 UCM. Oop, Vim didn't like that. All right, I'm not sure where I was running UCM, but somewhere. Okay, so welcome to Unison. Okay, this is actually a little bit too small. I mean big. Okay. There we go. So now it says, welcome to Unison. And we're at the Unison Codebase Manager prompt. So what I'm going to do is go into the namespace. So this is my code base. If I do ls, you can see all the stuff that's in my code base. And you can see I was trying out that zebra thing here at the bottom, but I'm just going to start a new one. I'm going to call it Scratch on Zebra. Okay, name Zebra is empty. So the first thing we'll have to do is actually to grab the base library and install that in our namespace. So if you click that, it'll give you the instructions. Pull Unison public base latest to lib.base. Grab that, stick that in here, and it should install that. So if I go ls, I have now a lib, and in my lib there's the base library. So now I have access to all of the code that's in the base library. Okay, cool. So the way that Unison normally works is that you have your editor on one side and then the Unison Codebase Manager in another window. And if you scroll up here, you can see that it says I'm watching for changes to .u files under this directory here. So any file with a .u extension in this directory where I started UCM, and if it contains Unison code, it will evaluate it or compile it. So if I begin a line with a greater than sign like this, and I say like 10 plus 2, and save it, it'll go and evaluate it. Oh, okay. I don't know why that was so slow, but it was. Okay, so now we can grab the definitions that were in Exercism here. So this starts us out. Grab that. All right. Okay. So we got to figure out who owns the zebra and who drinks water. Okay. So the way I'm thinking about this is that, okay, so I have a Copilot on. That may be useful later, but it might generate a bunch of garbage. But so the way I'm thinking about this is that the rules, well, let's actually bring the rules up. So let's see. Here are the rules. So how do we see the rules? Actually, why don't we just copy these rules over to our editor. Just put that in, you can put it below the fold. So in Unison, if you put triple dash on a line, then everything below that is a comment. So we just put that in here. Okay, so the way I'm thinking about this is that we need to use the each, and I'm thinking that this is going to be a little bit slow if we just like iterate over all the possibilities using each. So I'm seeing that a trick we could use is to maybe represent these as numbers. So we have fewer things to iterate over. So there are 5 houses. So I'm thinking about this as a 5-bit natural number. Okay? And then so each house will be a bit, and then the bit will be set if the house has that property. So for instance, if the Englishman lives in the first house, then the first bit will be set for the Englishman. Okay, so that's how I'm thinking about it, and we'll just go over each of the places in the bit, and then a completed solution will be one where the sum of all the numbers that represent that house is 1 1 1 1 1 binary. Okay, so I'm thinking of it as like okay, let's generate a function let's write a function that will generate all the houses. So call that each house is, it has a type each nat. Okay, so it's going to generate a bunch of natural numbers, and then each house will be each dot from list. I happen to know that you can turn a list into one of these each things. Oh, you need to do because this is a delayed computation. This little tick thing here means that it needs to use this each ability, and we can't do that sort of nakedly without guarding it with a do. So this becomes a computation that we can then force later using a different syntax. Okay, so do, so in each from list, we're going to do, so it's going to be 0x1 0. No, yeah. So that's the 5th bit set, and then 0x 8, 0 8, and then 0x 4. Oh, sorry, 0 4, and then 0 0 2, and 1. All right, so these are the 5 houses. 5th bit, 4th. Sorry. So the leftmost house will have the leftmost bit set. Right? Anyway, I think it makes sense. So I'm going to go with it. Oh, see, Deb says that each, not each from list. I think you're right about that. I think it's actually called each.each. So actually, we can just do this because I think that's a unique name. So in Unison, you don't have to write like imports and stuff as long as the names are unambiguous. You only need to do imports or use clauses if, like you could do, use each like this. So it'll use each from the namespace. So I can even do, base dot abilities dot each like this. But we don't need to do that because this is probably unambiguous as it is. Okay, so I think that's going to work. And let's see if that compiles. Open up our editor, save. Okay, so that compiles. So it's saying these definitions are okay to add. So it has compiled these things and it's ready to add them to our code base, which is literally a database. But I'm not going to do that. We're just going to edit this in our Scratch file here. And then once we have something, we're going to commit it to our our code base. Okay. So now we have each house, and what should we do? What should we do? What should we do next? I think that we should just write the solution. Okay. Oh, all of this stuff is in the zebra puzzle namespace. So let's use that convention. Zebra puzzle.each house, and then zebra puzzle.solve. Say, and that's going to be what is going to be the type of that? You know, it doesn't matter. Let's just start writing it, and we'll figure out what the type is later. Unison has type inference, so it'll be able to tell us. So I think I want... Oh, it's going to be a list. I think it's going to be a list of all the solutions that make sense. So I think I want to do each.toList. I'm pretty sure that's the thing. And so we say do. And then in here, we can do all this each stuff, right? And... you know, so we tell it what we want, and we tell it what the things we want to eliminate are, and then what's left should be a list of all the solutions that are logical. Okay, so let's see. There are 5 houses. The Englishman lives in the red house, so we want to say, well, why don't we start with something where we know what the house is. Okay, so here, the Norwegian lives in the first house. Great, so we say Norwegian equals 0x10. He's in the first house, which I assume is the leftmost house. All right? And, oh, milk is drunk in the middle house. So the middle house is 4. So we'll grab that. Milk is 4. And are there any others? No. Okay, everything else is sort of like relational. Okay, so these are the constants. These will come in handy. And now let's do the other ones, I suppose. Well, why don't we do all of the... Oh, this is cool. that's not right. So we want the Englishman to be... Well, what are actually all of the... What are all the... There should be 5, right? There should be 5 nationalities. So let's see. Englishman is each house. So we're going to consider each house where the Englishman might live. And Spaniard also lives in each house. And Ukrainian lives in each house. Who else lives in each house? Japanese. So that's 5. And we immediately want to eliminate, I think, all of the ones where the Englishman and like where 2 people live in the same house. We want to eliminate those. So, oh, it actually figures this out. Copilot. Well, it didn't figure it out quite right. Japanese plus Norwegian should be equal to 0x1f. Yes? 5 bits, all set. So that's what that means. These are only the solutions where nobody lives in the same house. No 2 people live in the same house. Okay? And we need to do this for all the other things too. So why don't we do red house. Okay, so there's red. This is going to be kind of tedious, isn't it? So why don't we do 2, 3, 4, 5. What other colors are there? There's blue. There's green. There's ivory. There's yellow. Right? There's green, blue. Okay, that's 1, 2, 3, 4, 5. Okay, that's all the colors. And now we want to eliminate where they aren't, you know, the same. Red, not read. Red, blue, green, ivory, yellow. So this is copy-paste coding at its finest, but it's going to be fast. And I think that's, for exercism, that's going to be important because, like, if you submit your solution to exercism and it like runs a little slow, then it just times out, and we'll all be sad. Okay, so we've done the colors and we've said that no two should be the same. Okay, so then there's the drinks. There's milk. Actually, why don't we do the milk? Why don't we do the drinks before, since we know a drink where it's drunk. Okay, there's coffee. That's going to be each house. 1, 2, 3, 4, 5. We need 3 more. There's tea. There is water. And there's 1 more. OJ. Oops. Orange juice. Oi. And we also want to say that no 2 people drink the same. So coffee. Tea. Oh, I forgot milk. Milk. Remember the milk. Water. And OJ. Okay. That should all sum to 1. And so what else was there? So there should be 5. Oh yeah, the smokes. Old gold, each house. There's Chesterfields, each house. There was Parliaments. I think it should be lowercase. Each house. And Luckies. All right, 1, 2, 3, 4. Oh, there's 1 more. Cools. Great. No, I just want to point out, smoking is not cool, kids. You should not do it. It's terrible. I used to do it. I quit. It was just smelly. It makes you feel awful. Okay. No, so now we got 1, 2, 3. We got 4 properties. There's 1 more, which is the pets. Dog. Yeah, this is right. 4, 5. Actually, can Copilot figure this out now? Snails, horse, fox. Oh, wait. It generates too much code. Well, we can go back and just get rid of all this nonsense. Oh, wait. Oh, we figured this out too. Excellent. There. So now we've done that. And now let's see if we have all the rules. The Englishman lives in the red house. So we want to say, oh, wow, it already figured it out based on the context in the below. Okay, that is what we want. We want Englishman to be equal to red. Oh, am I guarding colors instead of... Okay. Smokes. Oh, yeah. This should be old gold. Thanks, chat. Chesterfields. Parliaments. Luckies. And cools. Okay. Right, so the Englishman should live in the red house. Coffee is in the greenhouse. Ukrainian, did I misspell Ukrainian? Yeah, Ukrainian. It's Ukraine, not Ukraine. Ukraina. Ukrainian, what is he? T. And Oh, this one's interesting. So the greenhouse immediately to the right of the ivory house. So, okay, guard that the green should be equal to, well, nat dot shift right. Ivory 1, right? Aha. And then let's see. Okay, wait. Greenhouse means old gold smoker owns snails. Okay, old gold is snails. I'm sorry, this is a little uninteresting and tedious, but we'll get through it. Cools smoked in the yellow house. Milk. Oh, milk. We already had that. Milk is a constant in the middle house. House number 4. Okay, Norwegian lives in the first house. We already have that. Chesterfield lives in the house next to the man with the fox. So it's okay. So that should be Chesterfield's is equal to nat dot shift right. Fox. Or Chesterfield's equals nat dot shift left. Fox 1, right? I feel like that's probably the most concise way of saying that. I can think of a bit operation to say that a bit should be either on either side of another bit. Okay. Lucky's, let's see. Cools are smoked in the house next to, okay, so this next, why don't we lift this to a function? So guard, why don't we guard in the function too? Just say next to Chesterfield's fox. Okay, and then up here we'll do zebra puzzle dot next to should be each of Boolean, right? No. Unit? Actually, we'll just let it figure it out. We don't care. Guard. Next to A, next to B. So A is either B shifted right 1, or it is B shifted left 1. I don't know what the type of this is. It doesn't matter. We'll figure it out. The Unison will figure it out for us. So, do we need a do? Where do we need a do? Paul says we need a do. Oh, disregard. Okay, disregard it. I don't think so. I think what Paul is thinking about in the chat is that this uses an ability. And so here we're using a do to guard this ability because, you know, we need to actually force this to, like, we need to pass it a unit in order to make this happen. But here, this function takes 2 arguments. And so it's guarded by a lambda, to separate from this guard thing here. But so this is a function. And so the result of the function can use the ability because, you know, it doesn't do the abilities until we actually call the function. Great. Oh, Graph Bloodworth says, shouldn't this be an exclusive OR? Might not matter if A can only have a single one. Oh, should be an exclusive OR. Well, the thing is that this OR thing is lazy. So it actually won't even evaluate this part if this is true. So that's nice. But, well, okay, yeah. Okay, so it could be both, right? But in our case, we happen to know that there's only one bit set, so it definitely won't be both. But you're right. It technically should be one or the other, but not both, right? Yeah. Okay, we happen to know something about the input, that only one bit is going to be set. So then we want to do, wait, I lost track of the, next to cools is horse. And then luckies equals OJ. Oh, we need the guard. Guard luckies equals OJ, and then guard Japanese equals parliaments. And next to Norwegian blue. Oh, we don't need this parentheses. Okay, well, let's save this and see what it does. Okay, so we have some kind of syntax error here, obviously. New line or semicolon. I think this is just an indentation error, so we actually just want this. Because, like, I did guard and then, you know, started a new line with, like, less indentation, and that's not going to fly. Like, it lets you do this, but it doesn't let you do that. Okay. Oh, wow. So that compiles. Does it solve the... Oh, wait. Solve is unit. Oh, wow. Oh, we need to return. We need to return the solution. Right? Okay, so problem. Our solutions are just numbers. And we don't know which number is which. Well, we know which number is which. But Unison doesn't know which number is which. So I guess we got to tell it. So how do we do that? We got to map each. So it wants, I think, so let me see. Yes. Okay. So it wants text. So I'm assuming here it wants the text like Norwegian or something. So I think what we want to do is map the variables we have here to actual strings. Okay, well, let's use an actual map. Let's use a nat map because these are nats. Okay. Nationalities is nat map dot from list, and then well, it's gonna be well, no, Englishman is Englishman, etc. Right? You know, Copilot can help us with this for sure. Come on, Copilot. Yes. Oh, license MIT. Okay, great. Oh, I'm so glad we didn't have to write this. All right, I think this is going to work. Okay, so if you let me show you nat map. So nat map is a map whose keys are nat, right? And it maps them to some value of some type, and it's parameterized on the type of the values. And here's nat map from list. It constructs a map from a list of key value pairs, right? So it maps the nats to some value. So that's what I'm going to do here. Great. So this is all good. Orange juice. Okay, so now that we have that mapping, we should be able to just return the lookup. We got to look up each of these values that we have. You know, so like for each solution that makes sense, Englishman is going to have some value, some nat. And we want to look up that value in, you know, colors to know which house the Englishman lives in. Right? So I think that for each of the values, for each of the houses. So basically, for each house, we want to look up that house in all of the maps and construct. Okay, I think what we want is like a unique type. So not a structural type, but just a normal type called a unique type. And it's going to be house. Oh, zebra puzzle dot house. Let me check chat real quick. The famous Norwegian blue. You might want to move some guards in the map declaration up higher in the function. So C-dubs. Cody points out that some of these guards you might want to move some of these guards higher up. And yes, I agree with that. So probably, you want to use these guards here to eliminate the branches of this computation as early as possible. Because, if we do, for each house, this is like 5 to the power of 5 to the power of 5 or something. So that's a big number. If we didn't have any if we just did like each house for all of these and had no guards, we'd be doing like this like billions of times or something. And we'd have to run these guards for like billions of entries. So if we move them higher, then we won't have that issue. I actually think that this won't finish in any, like, until the heat death of the universe, as it currently stands. But we'll try it. Okay, so we're gonna do this house thing. Let's just make it a little record type thing. So every house has a resident, and that is bad text. It has a drink. It has a pet. It has a smoke. And, they smoke smokes. And they have, what was the last one again? Drink, what was it? Color. Text. What's chat saying? Can't move the maps up. Oh, I don't think we'll have to move the maps. So this is only going to, if the logic gods are in our favor, this will only be run once. There'll only be one solution that makes sense, and at the very end of it, there'll be one branch. All the other branches will have been eliminated, and this will only run once. All these map creations. Right? Okay. And now, I actually want to grab all these values. So I think I just want to do like each house, map over that, look up that house in these nat maps, and construct the houses. Does that sound like a plan? I think it's going to be okay. And if it's not, it's not going to be so bad. We will do something else. We got 20 minutes left of this hour that we have together here. Good of you to join. Okay. So I actually want to do I just want to do a list of each house because I want the list. Right? No? Yeah, because I want to map over the list. Oh, do I even need to do that? Can I actually just grab the house is each house, and then I look up the house. It's a house Oh, I need the right order here, because we don't actually have these are positional arguments to this thing. So it's a house with a, you know, not map.get resident with nationalities. Oh, it actually, yeah, Copilot is like on top of this. It's like, oh, I see what you're doing. Yeah. I think it's this. Oh, it's actually got it the wrong order, but okay, we can fix it. The color, the drink, the smoke, the smokes, and the pet. Right? Oh, I think they should return optional. We don't want that. It would be funny. It would be funny if we could turn on optional into an each, because then this would just run in the each. And since there's only one, right, it should work. Is there? Let's find out. So if we go back to UCM, find optional A to, so find anything of type optional A to each A. No. It's list of A. And then we can do each. Well, okay. Each to list. Yeah, I think this should work. Copy paste. Copy paste is so underrated, honestly. Oh, and it figures out how to do that rest of it. Well, it just generates too much code. Great. Oh, chat suggests just outputting the actual solution. Oh, I was gonna output like all the houses, but that is an interesting idea. Well, now that we've done this, yeah, I mean, I like that idea. We just output the solution to the, you know, let's grab this and put that here and comment it out there. But yeah, at the end, all we need. Okay, yeah. So who owns the zebra and who drinks the water? So we do get actually each of two lists of get netmap.get nationalities zebra. No. Who owns the what now? What was it? I forgot what the question was. Who drinks water and who owns the zebra? Great. Zebra. And zeb owner. And water drinker is get water. I think that should work. What is this? 93. Am I missing I'm missing parens. 93. Water. Couldn't find any definition matching. Oh, I do. I need to return it. So zebra owner and water drinker. Oh, so it returns a pair of text. The first one is the zebra owner, and the second one is the water drinker. Moment of truth. What's chat saying? One thing you can do if it's too slow is add guard, Englishman, Spaniard greater than 01F. Since if the sum of 2 elements exceeds that, the sum of 5 elements definitely cannot equals 01F. Oh, that's true. Partial sums, hacky, manual, branch, and bound. Oh, okay, yeah. There's a lot of stuff we can do to eliminate branches. Like for any 2 nationalities, we can eliminate them early if they clash, for sure. Okay. Let's solve it. Let's run it. So now it's running. Now evaluating any watch expressions. It's not looking good. I'm thinking this is not. It's already too long for exorcism. It's definitely not going to finish. Okay. So now I think what we got to do is just put all the rules we have as high as they can go. Right? As early as possible. So the Englishman lives in the red house. Let's grab that rule and say, well, once we have English and red, we're going to eliminate a branch. And then coffee and green. So once we have green and coffee, which is right after green, we're going to eliminate it. Ukrainian tea. Once we have tea, get rid of that branch. And once we have old gold and snails and green and ivory, so that's up here in the colors, right there. And cool and yellow. Once we have yellow and cools, Chesterfields and Fox. I feel like there's a lot of sort of cigarette guards. Cools. So maybe we should move the cigarettes higher. Ah, yes, the Norwegian blue. The famous Norwegian blue. Luckies. Yeah, I think we have to move the cigarettes higher. That might work. Well, let's see which was the parliaments. Right there. Oh, wait. We did the pets last. So we actually can't do cools and horse until after the horse. And we can just not do cools until we have to. Actually, that's a good strategy. We can also move the generators just before their guards, so we're not actually running other generators before we guard them. Let's see how this does. Oh, this needs the each ability but doesn't have access to it. Why? Oh, so this is a bad error message, but I think what this error message is trying to tell us is that this is a forward reference to snails. So it's not ready. Same for this one. Chesterfields, Fox. Okay, 43. Luckies. Oh, I moved some of the cigarettes below. Okay, well, that's okay. This was the last one. Okay, is that going to be... Oh, wow. That was much, much faster. Okay, so now it's saying Ukrainian is Norwegian, the Norwegian is Norwegian, the Japanese is Norwegian. No, okay, so these are all the solutions. Okay, so we're missing something. Because these solutions, these are the ones that make logical sense. So we have too many solutions. We must be missing a guard, or one of our guards is wrong. Yeah? Snails is below old gold. Oh, I think we fixed it. Right. Okay, so I think we have something's wrong here. We probably just like left something out. So I guess we got to go through all of our rules. Okay, so this one's definitely right. English, Spanish, Ukrainian, Japanese. Do we forget a rule? That's the question. Oh, it's going to be tough to figure that out. Let's see. What are the rules? The Englishman lives in the red house. We have that one. The Spaniard owns the dog. Oh, we don't have that one. Oh, that was easy. We found it. Dog, guard, Spaniard, dog. Ah! That's the solution. There we go. So the Japanese person drinks water, and the Norwegian owns the zebra. I think that's the answer. Sweet. So then, just grab all this code. Go to exorcism. See here. Put that in there. I'm not sure it does well with folds. I just don't know. Let's get rid of this. So instead of to do, we're going to now do solve. Oh, it's going to be at 1 solve, at 2 solve. Does that work? No. Let's see. At 2 has type. Oh, it's a list. It's a list. Of course, because each returns a list. Well, map at 1 over solve, and then why don't we just do that? Text.join. It's only gonna have one value, so whatever. Oops, wrong line. Text.join, not coin. Join. Map at 2 solve. That should do it. Oh, is it going to be too slow? It was pretty fast in UCM. Oh, your test timed out. No. Let's try again. Maybe it was just slow the first time. Well, we got 5 more minutes. Test runners are having issues lately, I'm told. In the chat, Rebecca says, test runners are having issues. Yeah, you know, this is cloud computing. Maybe shared resources. Lots of people running tests. So let's see. Well, maybe we can make this faster by, you know, rejiggering some of these things. So, you know, We don't need the Englishman until, you know, we need it. Oh, but then we can't guard here. Oh, that's fine. Like that. And we don't need the Spaniard until there. Oops. Oh, then all of these sort of same house guards are going to go. Well, I feel like these are going to be a lot less selective, maybe. Although, I don't know. Maybe not. Well, we could start eliminating in other ways. So, like, let's undo all this stuff. Yeah, Spaniard, it has the dog. I mean, like, right away we can say that, like, the Englishman and the Norwegian should not be in the same house. Right? So, like, they should be distinct. So stuff like this, I guess we could do to make this faster. And then, like, here. I guess, let's see what happens if we eliminate a lot of this tree early. So if we say the Spaniard, it's not the Englishman, and also the Norwegian is not the Spaniard. This is going to run like marginally faster, but that might be enough. We could do it for all of them. Actually, I can just do it in here in this editor. Make this. There. Oh, can we run solve only once? Well, we could. Like, we do like a mutable memo of this thing. The issue is it wants like just some text. It doesn't allow us to do anything else. So it would be nice if it would allow us to like return the pair or something to these functions. But like, this isn't allowed to have any effects. Like, we can't like mutate stuff. That's not very nice. Well, we're almost out of time, but I'm confident that we can make these rules line up somehow, so that it would work. So let's see. Okay, I'm gonna try one more time. Oops. Oh, oops. Sorry. Actually, just rejiggering these. Here. Okay, well, we could rearrange the rules in some way that would make this a little faster. But it's already pretty fast, I feel, in UCM. So it's probably just the test runners having some issues. So, you know, exorcism is maybe more popular today than on any other day. But anyway, time's up. thank you so much for joining, and please come and join the Unison Discord, the Slack, and join the Unison community, and come code with us. Thank you. Have a beautiful day.